Hello. Today, we would like to show you a demonstration about the different neoprene used to make wetsuits. This is a pressure chamber used to test the accuracy of depth gauges and diving computers. We are using the pressure chamber to simulate diving profiles and the effect on wetsuit material. All wetsuit neoprene is not the same in composition. Domestic neoprene from Rubbertex is composed of nearly 100% neoprene and is formulated through an extrusion process, creating nitrogen cells to withstand the pressures of diving. Imported neoprenes are 30 to 60% neoprene, blended with plastic polymers, which does not have the added nitrogen cells to withstand the pressure of diving. In the pressure chamber, we have placed samples of Rubbertex neoprene on the top shelf. On the remaining shelves, we have placed imported blended neoprene from Chaco, Pacific Eagle, and Yamamoto. On the left side of each shelf are 3mm samples, and on the right side are 5mm samples. We will now take you on a simulated dive of 35, 70, 100, and 130 feet. Please watch the effects of pressure on the samples. We're now at 35 feet deep. The samples have all lost a little thickness in the first atmosphere. As we go to 70 feet, the Rubbertex samples stabilize, but the blended samples continue to lose thickness. We're now at 70 feet, and as you can see, the Rubbertex samples are the same thickness as they were at 35 feet. The imported blended samples are 1/2 or less their thickness at the surface. We're now at 100 feet. The imported blended material has lost the majority of its thickness. The 5mm samples are less than 3mm, and the 3mm samples are about 1mm thick. The Rubbertex samples still retain the majority of their thickness. We now have reached sport diving limitations of 130 feet. The Rubbertex samples are still the same thickness they were at 35 feet, offering the diver proper thermal insulation throughout their dive. Again, as you can see, the imported blended neoprene have lost the majority of their thickness, almost a complete loss of thermal insulating the deeper you dive. And since the imported blended neoprenes continue to lose thickness as a diver goes deeper, the diver becomes severely overweighted. This makes it very difficult to maintain neutral buoyancy and can become dangerous during surfacing if air added to the buoyancy compensator is not exhausted properly. Since Rubbertex neoprene stabilizes after the first atmosphere, it is very easy to obtain and maintain neutral buoyancy. Finally, suits made from neoprene blends will lose up to 20% of their original thickness permanently in as few as 30 to 40 dives and become very stiff, making the suit harder to get into. After approximately 80 dives, a blended neoprene suit loses virtually all of its stretch, making the suit almost impossible to put on. Suits made from Rubbertex 2100 neoprene will continue to offer superior elasticity and thermal insulating characteristics, 3 to 10 times longer than blended neoprene wetsuits. A 3mm suit will last approximately 300 to 400 dives. A 5mm suit, 500 to 600 dives. And a 7mm suit, as much as 800 dives. Thank you for taking the time to watch this demonstration. We hope you now have a better understanding of the differences in neoprenes when making your decision to purchase a wetsuit. Choose Rubbertex for durability and comfort. Call for more information or visit our website.